Kristen May here for a Wild Wednesday. Today we are going to be learning about why wetland vegetation is so important. If you want to follow along, we have a worksheet available for free download on our Google Drive, and the link to our Google Drive will be in the video description below. Here in the low country, we have two different types of wetlands. We have a freshwater wetland or a swamp, and we have saltwater wetlands or salt marshes. Wetlands are important for many reasons, but today we are just going to focus on why the wetland vegetation is important. Do you have any guesses? Why do you think that plants that grow in the wetlands might be important? Why might they be important for the ecosystem? Why might they be important for the animals that live in that ecosystem? I want you to pause this video and I want you to take a guess. I want you to make a hypothesis. Why do you think wetland plants or wetland vegetation is so important? Remember, when you're making a hypothesis, there are no wrong answers. A hypothesis is just what you think you are going to learn. So pause this video and make a hypothesis. Why do you think wetland plants are so important? Now that you've made a hypothesis, let's talk about it. Do you think that different animals live in wetlands? Well, take a look around me. Of course, animals live in wetlands. A lot of different animals choose to make the wetland their habitats, their homes. Are plants important for different types of animals? Absolutely. One of the reasons why they're important is they act like a habitat or shelter for specific animals. Animals like macroinvertebrates, reptiles, amphibians, birds, and fish use plants as shelter as their homes. Why else might plants be important for animals? Well, do some animals eat plants? 100%. A lot of different animals eat plants. Animals that live in the wetland ecosystem eat the wetland vegetation, the wetland plants that grow in the wetlands. Would these animals in the wetlands be able to survive without shelter or without food? Absolutely not. Food and shelter are two of the main resources that all animals have to have in order to be able to survive. Another important thing about wetland vegetation is wetland plants actually help prevent erosion. What does erosion mean? Erosion means that soil is being moved from different areas. And if a wetland experiences too much erosion, it can disrupt the entire ecosystem. So there are two ways that wetland vegetation can prevent soil erosion. One way is wetland plants actually act like a barrier themselves. And when water comes in, the barrier of the plants can absorb some of the force of the water and prevent the water from taking away some of the soil, from eroding the soil. Another way that plants prevent erosion is the plant roots are all crisscrossed and interconnected down underneath the soil. And all of these roots being underneath the soil help stabilize and strengthen the soil so the soil doesn't get moved or doesn't get eroded as easily. So those are a few reasons why wetland vegetation is important for the ecosystem itself and important for the animals that live in the ecosystem. But wetland vegetation is also important for us. How? Let's think about the main part of a plant. When I think about a plant, the main parts I think of are the leaves, the stem, and the roots. What does a plant use its roots for? To soak up water. Plant roots kind of act like straws to suck up water into their stem and into their leaves. Several plants in a wetland actually grow with their roots directly in the water. A lot of our wetlands are near roads and houses and people, and sadly, we don't always take care of our wetlands. We pollute. When we pollute, chemicals or pollutants like pesticides, fertilizers, gas, and oil get carried away by rain runoff and stormwater. When these pollutants get carried by the runoff, it winds up in other ecosystems like the water in our wetlands. So when wetland vegetation starts sucking up that water from the wetlands, they are also sucking up the pollutants that have dissolved in the wetland water. These pollutants that the vegetation roots suck up are then stored in the plant's stem and the plant's leaves. So how does that help us? Well, since the wetland vegetation is sucking up some of the dissolved pollutants, any water that runs through wetlands actually gets filtered. It gets made cleaner by the wetland vegetation as it makes its way into our bigger bodies of water like rivers and creeks and lakes and the ocean. Water that we use for a lot of different things. Things like fishing and boating and swimming. Water that we even get our drinking water from. So wetland vegetation helps this water that we depend on be cleaner. So I've told you that wetland vegetation can filter out pollutants, but you might not believe me, so I want to prove it to you. So that means it's time for an experiment. This experiment is really easy to do at home. Instructions are on the worksheet for this video, uploaded for free download onto our Google Drive. And again, the link to our Google Drive is in the video description down below. All you need for this experiment is a clear glass filled with water about halfway up, some blue or red food dye, a paper towel, a knife, and a stick of celery. I recommend getting celery that still has some leaves on it. The glass of water is going to represent the water in our wetlands, and the stalk of celery is going to represent our wetland plants or our wetland vegetation. So the first thing that we're going to do is we are going to take our stalk of celery, and with the help of an adult, I want you to cut about the bottom ½ inch of that celery stalk off. The only reason we're doing that is I just want a clean cut with that celery stalk. The next thing we're going to do is we are going to put several drops of our food dye into our glass of water. Now remember, this cup of water represents our wetland and the water in the wetlands. We are going to put our food dye into the wetland. So let's think about, why are we doing this experiment? We want to show how wetland vegetation can soak up pollution that might be in the water of our wetlands. So as you put several drops of food dye into your glass of water, into your wetland, I want you to think about, what does this food dye represent? It represents all the different types of pollutants that can wind up in our wetlands. So now that we've polluted our wetland, let's swirl it around a little bit. And if you don't have food dye, you can actually just use a marker you don't mind ruining a little bit. Take the cap off and swirl it around in the water. And now let's add our wetland vegetation, our celery stalk, into our polluted wetland. So now we are going to let this sit overnight, at least 8 to 10 hours, and then we are going to come back in the morning and we're going to see what happened. What do you think is going to happen to your celery stalk? I want you to make a hypothesis. Pause this video, make a hypothesis, and then come back tomorrow morning. So we let this celery stalk stay in our colored water for about 12 hours. Let's take a closer look and see if we can notice some changes in our celery. Do you see the blue tint of the leaves? Now, why did that happen? Why do you think that happened? What does that represent? So now that we have let our celery stalk stay in our water overnight, we're going to take out our celery stalk and we're going to put it on our paper towel. Now let's come in closer and make a few observations. So we already looked at the leaves. Now let's look at the bottom of the celery stalk. It turned blue. So what do you think that means? That means that the celery stalk took up some of that colored water, took up some of the food dye, just like how wetland vegetation takes up pollutants in wetlands. All right, now let's take a little bit of a closer look. With the help of an adult, I want you to start cutting your celery stalk in about 1-inch increments. Let's take a look at these increments. Do you notice how the holes of the celery stalk are darker in color than the rest, let's turn it around. Look at that. Look at the holes of the celery stalk. So where on your piece of celery was the water and was the food dye traveling up through? It was traveling up through these veins, just like how wetland vegetation takes water up through its roots and it travels up through the stem and then to the leaves. Let's keep looking at these cut off pieces. You see how we can see where the food dye was traveling up the celery stalk? This is called a cross section. I want you to draw a cross section of your celery stalk, and if you have colors, you can even color in the veins to show how you have observed how the food dye and the water travels up the celery stalk. All the way to the very top, you can still see the food dye traveled all the way up our celery stalk through these veins. Now, let's look at the most interesting part, the leaves. Do you see how blue these leaves are? How the food dye went all the way out into its leaves? Look at the very top of the celery stalk. You can even see the veins went all the way up to the very top. The food dye traveled all the way up to the very top. And so while we're looking at these beautiful leaves, and this is why I told you to try to pick a celery stalk that has leaves, because it's very cool to see how the food dye travels through the stem up through the leaves. Let's think about what this represents. What was this experiment trying to show us? This experiment was trying to show us how wetland vegetation can suck up some of the pollutants that might be in wetland water, and that filters the water and makes the water a little bit cleaner. Did this experiment prove that to us? I think it did. Remember, the food dye represents the pollutants. The pollutants traveled all the way up the celery stalk through the veins of the celery and out through the leaves, just like wetland vegetation takes up pollution and it can be stored in the stems and the leaves of the wetland vegetation. Now, take a look at your wetland, your cup of water. Was our wetland vegetation, our celery stalk, able to get all of the color out of our wetland? No. So do you think that wetland vegetation can get rid of all of the pollution that ends up in our wetlands? Absolutely not. In addition, if there's a lot of pollution in our wetlands, do you think that plants are going to be able to survive if there's too much pollution? No, too much pollution is going to kill wetland vegetation, is going to get rid of all of those benefits that wetland plants provide, and it can end up destroying the entire wetland ecosystem. So if you were a scientist out in a wetland studying either a swamp or a salt marsh, and you took a look at the vegetation around you, and you noticed that the plants were all dying or already dead, what might that be a sign of? Would that be a sign that that is a healthy ecosystem or an unhealthy, polluted ecosystem if all of the wetland vegetation is dying? What do you think that might mean? So through this video and your experiment, you have learned why wetland vegetation is so important. Now I want you to think about how you and your family can work to help protect the important wetland vegetation and the important wetland ecosystem. What are some of the things that you guys can do to help protect these very important places? Now that we're all done with our experiment, don't forget to help clean up, and I will see you next Wednesday. Stay wild!